So today our presenter is Dr. Bryan Unruh. He is a professor in environmental horticulture, specializing in turfgrass. He's also the Associate Center Director for West Florida Research and Education. I think that's in J, correct me if I'm wrong. And uh, Bryan is certainly our expert in turf grass. We have other turf grass specialists across the state, but he is leading the way in many cases. He has many graduate students, and he has done amazing research. And he is a great supporter of Extension and the Master Gardener program. He's here to help us, and he's here to educate us. So, Bryan, please, we welcome you to the state webinar, and please go ahead and share whenever it is comfortable for you to do so.
All righty. Well, I appreciate the opportunity to be here. I got to hang out with Master Gardeners yesterday. I was down in Walton County, and Master Gardeners are one of my favorite groups because they are the most challenging. They keep me on my toes, and it's been interesting over time. I kind of have to. It's funny. I typically ask two questions. Or make two statements when I work with Master Gardeners. And it's a weird statement because I generally ask Master Gardeners, how many of you leave the water running when you brush your teeth? And it's a really weird question, but I start out almost all of my presentations that way because I oftentimes am speaking about water quantity, how much water we use in the landscape, as well as water quality. And it's very interesting. About 50% of Master Gardeners leave the water running when they brush their teeth. And it's interesting because we talk about water conservation, and then I ask the question, well, why do we leave the water running when we brush our teeth? And it's because it's habit. There's no other real reason. I mean, but it's habit, and habits are really hard to change. And so when we think about managing turf or managing the landscape, a lot of times we get kind of these ingrained habits, and we do things because we've always done it that way. And it isn't necessarily the best. And so I want to share my screen. Are we sharing the right screen? Is it sharing?
Looks good to me. Looks good to me. I'm going to go ahead and stop my video, but I am here if you need me, and I will shoot questions to you for points of clarity, but go ahead and take it away. It looks great from my end.
Okay, so you're seeing my title slide. That's a good thing. So the second thing that I typically start every Master Gardener presentation out with is the fact that you Master Gardeners offer tremendous value, really, to the University of Florida and to the residents of Florida. And you are often our front line of defense, I often say, because you're a tremendous buffer between me. There's only one of me, and there's a whole bunch of Floridians. And Master Gardeners have that opportunity to intersect with a bunch of people, and it keeps my phone from blowing up. But whether it's you as a Master Gardener, Wendy as the Master Gardener coordinator, or me as a state specialist, we're in an interesting position where we can't really espouse our opinion about things. Whether you're a volunteer or whether you're a specialist, we're kind of bound to the evidence. And so I often joke, just because certain people recommend, putting a pie pan full of beer in the garden and the slugs will drown or whatever they do, that's not a recommendation we can make because it's not an evidence-based recommendation. It's not based off of sound science. And so when we think about that, and our topic today really is dealing with turf and soil testing and kind of an update on that, there's a lot of misinformation that gets put out there, and even kind of some old wives' tales and different things that get put out and will get promulgated along the way. And I think we have to be very careful that we're not pushing information out there that is not based on good sound science, whether it's you interacting with the public or whether it's me as a specialist. I cannot put out stuff that's not based off of good science. And so if we jump into this, let's talk about kind of this great debate, and it's something internally at UF we've been dealing with for a number of years. But it's just this general kind of this idea, that urban landscapes have, or they contribute to the degrading of Florida's water quality. and what is the role of the landscape as it relates to water quality. And water quality concerns are valid. I don't think anybody should or could argue that. Where the argument typically takes place is who's at fault. And it's interesting because when we delve into, and you can see this little graphic on the right of the screen, a map of Florida, and you see these green areas and the little blue squigglies. Those are areas where water is impaired. And so when we think about that, what is causing the impairment? And there's a whole list of things. If you flush the toilet this morning or today, you're part of the problem, okay? Because that's a waste product. If you're filling up your vehicle at the wall and you got the little automatic, the thing that holds your lever on, and it pops or whatever, it's a little bit late and it spews a little bit of fuel out on the ground. Hopefully it missed your shoes, but you've contributed to some pollution. If you took your dog for a walk and the dog did his thing, then the dog contributed to some pollution. And so water quality concerns are quite valid in Florida. And we have a lot of people that continue to move to the state of Florida every day of the year. And many of those people that move to Florida desire to have this beautiful landscape. And so then we have kind of this issue. And a lot of times these landscapes are not being managed properly, and then we can have some challenges. And so we see, different groups have put out these different types of, public service announcements and stuff. And so this one here, when you're fertilizing the lawn, remember you're not just fertilizing the lawn. And so you see this guy, and there's this assumption being made here that when we fertilize the lawn or the landscape, that we are in essence putting putting fertilizer into the waterways. And it says, you fertilize the lawn, then it rains, the rain washes the fertilizer along the curb into the storm drain and directly into our waterways. The nutrients encourage algae to grow, using up oxygen that fish need to survive, resulting in fish kills. So if you fertilize, please follow directions and use sparingly. So part of that is accurate. But the one piece that's a little bit that says, we fertilize the lawn and then the fertilizer gets washed along the curb. Well, if we put the fertilizer on the lawn, it didn't get washed along the curb. And so that's where this wrestle. And so turf has been the target. Turf grass has been the target of a lot of fertilizer ordinances. We have in excess of 130 fertilizer ordinances in the state of Florida today. Many are targeted at the lawn as opposed to really the landscape. But it's interesting. We've done a little bit of homework or just out traveling. And so these are, the base of some palms that are out there. And even the fertilization practices on palms, if you can see where my understanding is they kind of have this soup can approach. And so they scoop, a soup can full of palm fertilizer and they sprinkle it at the base of the tree. And so I went and was curious about this and actually looked at our, palm fertilization recommendations. And then I started doing a little bit of math just for comparison purposes. And I put the math there. There won't be a test on this, I promise. But if we use this recommended 8 to 12-4 fertilizer at the 1.5 pounds per 100 square feet, when you ultimately do the math, and then it's suggested that you do this every 3 months, we're putting out 4.8 pounds of nitrogen per 1,000 square foot on that palm. Well, that's in some cases exceeds the turfgrass fertilizer recommendation. And we're concentrating this fertilizer to a spot. And a lot of times it's these mulched areas, granted, there are probably a few roots below this, but there's a concern here that, even our palm fertilizer recommendations can have impairment. Now, you think about some of these palms, that are, $1,000 or $2,000 or $10,000 a pop. You can see why this, they're really wanting to take a special care of these palms. Well, let's run down to the retail stores and look at some products out there. And this one here, this Bold Blooms for flowering plant food, the NPK ratio is 15-30-15. So this thing is loaded with phosphorus. And we have phosphorus restrictions on the lawn in the state of Florida, but yet we can turn around and allow phosphorus to be applied here. And it's what's interesting is I look this bag over and over and over, and there's actually no coverage information on the label. So even how much of this product do you apply per unit area, it's not listed on the label that I could find. There's another product here, a tree, shrub, and evergreen fertilizer. And so, and this is obviously based on how much to apply, and it's, half a cup, per unit area or a cup per unit area. And then it has, kind of how often do you apply. And it's interesting if you were to follow the label, which we encourage people to follow the label, we'd be putting out 2.4 pounds of nitrogen per 1,000 square foot per year, which is very similar to what even our turfgrass fertilizer recommendations are. And so when we think about this, I think we've got to be careful that we just don't pinpoint one aspect of the landscape and realize that a lot of fertilizers going down on some of these sites. Well, kind of to address many of these water quality challenges, I'm the old guy at the University of Florida, and really back in the year 2000, that's where the first fertilizer ordinance popped up in the state of Florida. And that then prompted a team of scientists and a team of regulatory folks, and then ultimately a big team of even stakeholders came together. And that's when the green industry BMPs were first developed. And then from there, we've seen the Florida Friendly Landscaping Handbook for Home Lawns. We have golf course BMPs. We have sod production BMPs. And we literally are just signing an agreement right now with the Department of Environmental Protection to write the best management practices manual for athletic fields. And so we have these guiding documents that help us to properly educate, whether it's a homeowner or a master gardener or the green industry professional, golf course superintendent, or sod producer, on the best ways to manage these sites. Well, I like to talk about water, light, temperature, and nutrition. And growing plants, whether it's turfgrass or landscape plants or whatever they are, these are the drivers. And so water, light, temperature, and nutrition. Now we're going to focus on the nutrition piece here in our time together today, but really water, light, and temperature are the big drivers for plant growth and development. Water typically is too much. We know that most people tend to over irrigate. And we live in a state that, generally speaking, gets an abundance of rainfall, but yet we have sandy soils. And so we don't have the ability to retain a lot of that water, that rain that falls. When we think about light, sunlight coming down, of course, we deal with shaded landscapes. We deal with, and it's not uniform. I mean, we have, a front yard that has a lot of sun and a backyard maybe that receives, a lot of tree shade, canopy cover. And so light becomes a big one. And then temperature, and especially as we move in north in the state of Florida, we get some pretty cold temperatures. And then we see just over time, these hardiness zone maps are starting to change just because of various changes in temperature. But this nutrition piece, again, is what we'll speak about here for the rest of our time together. And when we think about nutrition and fertilization best management practices, the goal of proper nutrient management should be to apply the minimum necessary nutrients to achieve acceptable quality, and then to apply those nutrients in a manner that maximizes the plant uptake of those nutrients. And so we focus on the center of this graphic here, this plant available nutrient pool. And so that is basically, what does the plant have available for it to draw its nutrition from? And we know there are a lot of inputs, and then there are a lot of outputs to that plant available nutrient pool. Those inputs include minerals from soil. It includes fertilization, so we're actually spreading some fertilizer. We know that our reclaimed water that we use in a lot of landscapes, which is of tremendous value, also can contain some nutrients, especially old reclaimed water treatment facilities. We I'll throw a term out there called advanced wastewater treatment. And the advanced wastewater treatment, part of the process of cleaning that water up is to remove nutrients. But we have many of our older wastewater treatment facilities in Florida that are not advanced wastewater. And so the water that is coming out of those sites typically have some fairly elevated levels of nitrogen and phosphorus, again, that are contributed to that plant available nutrient pool. Then we talk about atmospheric deposition. So that's the fancy phrase for rain and the nutrients that come with that rainwater. And in Florida, surprisingly, we get a lot of atmospheric deposition of nutrients from rain. And then we see the deposition of organic residues. And so just when we think about returning clippings to the lawn, or we think about adding compost, we can add nutrients to this plant available nutrient pool. Then there's the output side of things, and that's where clipping removal, or if you're deadheading plants or removing different plants from the landscape, you will take some of those nutrients away from this plant available nutrient pool. We know that we have some gaseous losses. We know that our soils are constantly turning over in the nutrients, and I'll show that pictorially here in a bit. But there can be a conversion to unavailable forms. And then that last one is this leaching and runoff loss. And those are true losses, and those are where we see our environmental issues tend to crop up with these. And so leaching and runoff losses are a big focus of research. And how do we mitigate some of those? Well, for the time together, we're going to focus more on this minerals from the soil. And when we think about it, I'll take you back, maybe back to junior high or high school. And if you recall the periodic table of the elements. And so these are all of the elements that are in soils or in our rocks. And when we think about that, the three that are circled in yellow, that's hydrogen, carbon, and oxygen. Of course, those are abundant. And then we see the blue circles and the red circles. Now, the red circles, that's the nitrogen, the phosphorus, and the potassium. So the first three, those three numbers on a fertilizer bag, they didn't just jump in the bag. They were in our soils, and then they typically are mined out of our soils and then converted through various processes to make fertilizer. But our soil still contain those elements. And then we see the blue circles, and those are our secondary nutrients or our micronutrients. Again, these are in the soil. Sometimes they're in our water. And so these are all those elements that are contributing to the plant growth. And so as we think about this and we start thinking about soil testing, we look at soil analysis interpretation. And so what we want to know is from our soil, how much of those nutrients are there, and are they available for that plant to be able to use? And when we think about the tenets of proper soil testing, there are four. And the first one is sampling, the second is testing, the third is interpretation, and the fourth are the actual recommendations that come forth from that soil test. And so let's jump in and look at sampling to start with. And this is probably the greatest source of error when we think about accurately determining what is in the soil and then what is available for those plants to use. And this doesn't matter whether we're dealing with turfgrass or whether we're dealing with vegetables in the vegetable garden. And so when we think about soil sampling depth, that's where we need to make sure that we're being very conscientious to pull a sample from the depth in which those roots are going to grow. And so for a landscape plant, generally speaking, for turfgrass in particular, we want to focus on that upper 4 inches. And so when we take our probe and we go pull the soil, we want to make sure that we're staying in the 4 inches, because that is where those roots, by and large, are going to congregate. And it's the roots then that are going to take those nutrients that are in the soil and assimilate them into the plant. And so again, this is probably the sampling process is probably the greatest source of error of all. We want to then use a soil probe or a garden spade and take 10 or 15 random samples from the areas that we're looking at. And we want to avoid mixing soil from healthy areas of the landscape with soil from unhealthy areas of the landscape, as then that just kind of makes it much more difficult to try to interpret, is there a deficiency that is there? If we take soil from healthy areas and not so healthy areas and mix them all together, we're going to get an average back. And then again, that will not allow us to define or be definitive in what's happening. And then we want to thoroughly mix the soil from those samples that we've taken. And then typically we're going to send about a 1 pint portion of soil. We're going to put it in the soil bag, in the sample bag, and that's what's going to the lab. Now, if we have a fairly uniform landscape, and so we look at this house here in the middle, and if we just, from an aerial image looking down, it looks like the lawn in this case is pretty uniform. And so in this particular case, maybe a single sample was sufficient to go to the lab. If we look at this and we see where these stars are denoting where we would want to pulse the soil from, again, put a little bit in the bucket from the 4-inch depth, mix it together, and then we take a portion of that out, put it in the sample bag, and that's what heads to the lab. Look over here at the neighbors. We can see some variation. Now, whether or not this is due to soil or whether it's due to drought, this is just an aerial image, but we can see kind of in this middle section, things aren't looking too good. Maybe up here in the front yard, something up here is not looking too great either. Now, we interestingly here in Florida, we have a lot of bulkhead soils. And so in a situation like this, chances are the soil in the front of the lawn is probably what was there to begin with. But because this bulkhead was built along this water body, most of the soil that's going to be backfilled into that bulkhead area is fill soil. It's filled dirt that came from somewhere. And so in a situation like this, we probably want to take a sample from the front yard, and then we would want to take a sample from the backyard. And I'll show you an example of a soil test report here in a second as to where some of these differences can really show up. And so we've done the sampling. That's physically going to the landscape, pulling the soil, mixing it, putting it in the bag that's heading to the lab. The second is the actual testing process. And so once that soil has arrived at the laboratory, then they set in and start the process of testing the soil that was sent in. And so soil testing procedures focus on what we call an extraction or a digestion of the sample that was sent in. And so the purpose of the extractant, and it's a chemical, it is designed to chemically extract, as the name implies, the elements from the soil. And then we're going to correlate that to what the plant uptake would be during the growing season. And so the method that is employed, the extraction or the digestion method, is specific to the nutrients that we're trying to test for. It's specific to the geographic region, and then also of the makeup or the mineralogical nature of the sampling site. So this little picture you see here, these are little crucibles, so they're little ceramic cups. And when the soil comes into the lab, they're going to measure out a little bit from that bag, and then they're going to put it in these little crucibles, and then they will add an extractant or this chemical to that soil. They're going to stir it up, and then they are going to take this liquid and then run it through a machine. And so the extractant is a chemical solution that contains some water and some acids and some certain organic chemicals that, as I said, is mixed with the soil that you collected, and then it has been sent to the lab. And upon mixing this chemical solution, as I said, it extracts the nutrients that are bound to the soil. And after mixing, then that sample's liquid portion is then filtered, and then they run it through the laboratory analytical equipment. to then give us the numbers that are showing up on our soil test report. And so the results of the liquid analysis are then converted back to a dried soil basis, and that is what we refer to as a soil test index value. And so when you get a soil test report back, it is this soil test index values that are typically reported. And you'll see them either as pounds per thousand, sometimes as parts per million, or if it's going to more of an ag-based laboratory, a lot of times it's pounds per acre. And what that values tell us typically is that is the amount, or it's an indication of the soil's ability to supply nutrients to the plant. And then a lot of times you'll see these ratings are very high or very low or low. And we'll talk more about those here in a bit. Now, these extraction methods, they differ. Okay, so depending on where you are in the United States. And again, it's based kind of off of the soils that are in those regions. Now, here in the Southeast United States, and specifically in Florida, our scientists have landed on using a Malic 3 extractant. Now, we're not going to get too far into the weeds on that, but they have determined that that is the best extractant to use for Florida soils. Now, where can this create a problem? First of all, these extractants that are used, we cannot convert, generally speaking, you cannot convert the results from one extractant and convert them to a different extractant. There's a little bit of an exception with the Malic 1 and the Malic 3. There are some conversion factors. Where this comes into play is if you, for some reason, buy a soil test kit or whatever, say out of the Midwest, and then you sample the soil and you put it in a little bag and you put it in the mail and it ends up in a lab in Illinois, for example, they probably are using an extractant that is different than what we would use in Florida. And so that when you see our recommendations for Florida, the numbers won't make sense because I said you can't convert these numbers. And so if you're in the Midwest region and they did a Bray 1 soil phosphorus test, you cannot take that number and try to make sense out of it from the Florida recommendations. And so we've kind of dug in deep here, I'm hoping I'm doing a good job explaining this. And so what we want to make sure is that we use a soil test that uses a Malic 3 extractant, because all of our University of Florida IFAS recommendations are based off of a Malic 3 extractant. And so we've covered the sampling, we've covered the testing. We said that sampling is where a lot of error gets introduced, and that's the piece that you typically are going to do or a commercial landscaper is going to do for a particular property. That soil then gets shipped off to the lab. Now, the labs have standards that they must meet. And so let's just make an assumption that the labs are all using a Malic 3 soil test. Chances are then the results are going to come back and they would be very uniform from one lab to the next, generally speaking, if they're using the same extractant methods. Then we get into the interpretation and the recommendations. And this is where considerable confusion and frustration can come into play. And I think if we step back and why this gets kind of why there's considerable confusion and frustration is because in our world, in the landscape world, the interpretations and the recommendations are a bit confusing because we don't really have good interpretations and recommendations for a lot of the nutrients for the plants that we grow. And let me explain that a little bit. If we go back to the premise of soil testing, it's all based off of agricultural commodities. And so let's say you were in Iowa and you were growing corn. and you were growing 150 bushel per acre corn, and you wanted to grow 175 bushel per acre corn, you would go to a chart that has been developed over time, and it would show your nutrient inputs on one axis and the yield on the other, and you would see a curve. And so then you would read across that and you would determine if I increase my nutrients so much, I would get an increase in yield. Well, in the landscape, whether it's the turf grass or whether it's your azaleas or your other landscape plants, we don't measure yield. In fact, in turf grass, in my world, we don't want a lot of yield, right? We don't want to be out there, swathing our lawn, and cutting off a lot of foliage. We're focused more on an aesthetic value. How does it look? How is it growing? When I think about football fields, how is that turf recovering from the injury, the damage that is being put on that turf as games are being played? And so we don't really measure yield. And so therefore, we've had a challenge with these interpretations and recommendations because we're not measuring yield. And so these recommendations oftentimes are more from a beauty pageant perspective, and we don't have calibrated curves for aesthetics. And so that's why this gets to be a little bit challenging. On top of that, we kind of have interpretation philosophy differences. And so one of these is kind of this, we get these numbers back from the lab and we want to build these numbers up and maintain them. And so soil nutrients in this philosophy are increased to the highest level, and then we maintain them based off of the plant removing the nutrients as that plant grows and develops. And we call that feed the soil approach. Now, there are some that subscribe to this base cation saturation. And so this philosophy says that when you look at a soil test report, and you've probably seen these where there's kind of this pie chart and it shows calcium and magnesium and potassium and hydrogen, and they want particular ratios of these elements. And we call that soil balancing. And then there's this sufficiency level interpretation philosophy, and that's where we add enough nutrients to meet the plant response goals. And once that goal has been met, then we don't want to put any more out there. And so these three interpretation philosophies can create additional confusion as well. And when we think about feed the soil, for example, that's where some would say, let's get the nutrient levels in the soil up as high as we can so that the plant never is in need or never has a want. Well, the problem with that is in our sandy soils in Florida, with a state that gets a lot of rainfall, if we've loaded up our soils with nutrients, especially nitrogen and phosphorus, then we have the real potential to lose some of those nutrients to leaching and runoff because we've built them up at a level higher than the plant actually needs. And so there's this extra amount of nutrient that is there that is greater than what the plant needs. The soil balancing piece that gets into these ratios, if you were to go into the scientific literature, most soil scientists dismiss this soil balancing approach as it does not really pan out in good research. I think the sufficiency level is a better approach, and that's where we're making sure that we have just the right amount of nutrient in the soil for the plant to be able to do what the plant needs to do. And so, Wendy, there is a hand raised. I don't know if we want to take that question now or how do we want to do that? You're running that show. Or do we do them at the end? We may want to do them at
Well,
the end.
we've got 8 questions in the question answer, and the ones I've been reviewing seem to be okay to hold down to the end.
Okay.
And I think we're good with that.
Okay. All right. Well, you monitor that and interrupt me if I miss something. So we take these 3 interpretation philosophies and we kind of move this forward a little bit. So this is a soil test report that comes from the University of Florida, and just for complete candid nature, we joke that you kind of need two PhDs to be able to understand what this report says. And so let's unpack it a little bit. So this is a sample that came in. We had a target pH of 6.5 up here. Then we see phosphorus, potassium, magnesium. And then we see these levels. So parts per million, 62, 41, 69. Then you see this interpretation here, high, medium, high. And again, when we think about that interpretation, where did those values come from? To say that it's high relative to, St. Augustine grass, or that it is medium compared, for a zoysia grass. And so again, there's kind of been this historical approach where they just kind of take all the crops together, whether it's an ag crop or a landscape crop, and they've come up with these values. In the turf world, we're moving more in the range of, is it sufficient or is it not sufficient? Again, because I said we don't have these calibrated response curves. Because what ultimately comes back on these recommendations, if you test low, medium, high, or very high, then you would historically get a response back. You need to add, if you're low, add this much. If you're high, you don't add anything. And if you're medium, you kind of add this middle amount. Well, again, we don't have these calibrated curves because we're not measuring yield, we're measuring an aesthetic. And so then you see these micronutrients here, or sulfur, copper, manganese, and then you see these levels. And then you see these lime and fertilizer recommendations. And so nitrogen here, 4 pounds per thousand, phosphorus, because we tested high, then it doesn't get any phosphorus recommendation. Potassium is coming back at a 1. And then you see all these footnotes. And anytime you add a footnote to anything, the difficulty of understanding starts going up. And so we're really good at generating a lot of footnotes for our lawns. Now, this is a report from a commercial lab, and this is one where I got called in to look at this, and this was the front yard, and then this was the backyard, and this was a bulkhead situation. The front yard in where they had this fill soil. And the front yard was performing one way and the backyard was performing completely different. But the lawn care company that was treating this property was treating it exactly the same, front yard and backyard, and then wondering why the results of the treatments were not doing what they wanted them to do. They had taken a soil test where they had taken soil from the front yard and the backyard, mixed it all together, and sent that off to the lab. And then when I saw the report, I'm like, that doesn't make really any, it's not telling us anything. We know the one portion of the yard's doing well, one portion of the yard's not, but the soil test, because it was an average between these, was not providing us very useful information. And so we went back and said, well, what does the front yard have and what does the backyard have? And you see they were very different. Soil pH of the front yard was 4.5. Soil pH of the backyard was 6.8. Then you see the nutrient levels, basically everything except for iron was low in the front yard. But in the backyard, we were moving into the medium range and adequate ranges for some of these other nutrients. And so in this case, then we were able to make a recommendation back. You need to treat the front yard in this way, and you treat the backyard in a different manner. Now, we do not test for nitrogen in Florida, well, really anywhere nationally. And that is because of the fact that nitrogen is very dynamic in nature, in the system. There's a lot of reactions going on in the soil. So you could take a sample today from a particular spot in the lawn, send that to the lab, take a sample tomorrow from the same spot in the yard, send it to the lab, and chances are you would get a very different number, even 24 hours apart. And so, again, we do not test for soil nitrogen, but our recommendations come back in 3 regions of Florida, north, central, and south, and that's really linked to the growing season, how long over, of those months. So in North Florida, most of our lawn grasses grow about 7 months, whereas in South Florida, they're growing year round. And then collectively, we've taken the kind of the beauty pageant science, how does the plant look, and we've paired it with the environmental data from, say, nutrient leaching to generate our recommendations. So we can see here Bahia grass is 1 to 2 pounds per year. St. Augustine is 2 to 4 in North Florida. And then as the growing season lengthens, as you go downstate, the amount of nutrient we would apply increases because of you have greater season. From 2004 to 2012, we did statewide, 3 locations, a tremendous amount of research looking at environmental fate of nutrients applied to the landscape. And as a result of that research, we've reduced our fertilizer rates, nitrogen rates, anywhere from 25 to 83%, lowered them because we know that our lawn grasses did not take as much. And so again, balance that beauty pageant with the environmental fate of these nutrients. And so these numbers have changed significantly over time. This is just a pictorial graphic showing you this is nitrogen, and this is why we don't test for nitrogen, because some of it is plant available. Some of it gets bound up in organic matter. Organic matter is releasing nitrogen back to the system. You've got turfgrass uptake. You've got, as we said earlier, atmospheric deposition. And so it's a very dynamic process in the system for nitrogen. Now, interestingly, there is kind of a movement afoot to try to identify or to develop soil tests for nitrogen. And we're starting to see what we call soil health reports coming out. And you will look on some soil test reports and you see the soil health and fertility analysis. So you get a fertility score and a soil health score. And they're interestingly, right here, you'll see a couple terms, and it's called Solvita and Solvita CO2 burst. What they're doing is they take some of the soil and then they do some specific tests on that soil, and they're measuring basically microbial respiration. So the microbes in the soil are breathing, and so they can quantify the CO2, what they call the CO2 burst, and then they can come up with a value that kind of gives an indication as to how much nitrogen are the microbes in the soils releasing for plant availability. Now, it's really cool research, but we're quite a ways from making good, sound scientific recommendations off of these methods. A lot of research is being done in this realm, but at the present time, I'm not comfortable with these recommendations yet. And so, again, a lot of research being done on this whole soil health movement. Agriculture as a whole is way ahead of us in the urban landscape. But I think it's exciting research, and it's really interesting to see this come along. Well, let's shift gears a little bit and talk about soil tests. And so we've talked about the University of Florida soil test that is done in our lab in Gainesville. And I want to show you a new, relatively new UF IFAS branded soil test kit powered by soilkit.com. And so this is a public-private partnership that have been fortunate to help bring about at the University of Florida. And a lot of it is based off of my 29 years at Florida and interacting with a lot of master gardeners, a lot of county agents saying we need help to be able to interpret our soil test reports. And so we launched this about a year ago, a little over a year ago, and it is an easy to use soil testing platform with a consumer friendly results interpretation online interface. That's kind of a mouthful. But this is a brand new soil test kit. It's physically a real simple little um, kit. And we'll talk a little bit more about that here as well. So what this kit does, again, it is University of Florida. It is using the exact same test methods that we do at our lab in Gainesville, but it's a value add. And so this information, the reports that come back off of this, provide direct linkages to UF IFAS resources, including our extension publications and our extension websites. The information contained here is linked to our fertilizer ordinance app that we have developed through the Florida Friendly Landscaping Program. You notice down here on the kit, the Florida Friendly Landscaping logo. And so it has all been part of it as we bring this thing forward. I mentioned the Florida fertilizer ordinances, and I'm going to take you into the portal here in a second. But we have linked the fertilizer ordinances information to the soil test reports. Well, what does that mean? I had mentioned earlier that we have about 130 some fertilizer ordinances, restrictive ordinances in Florida. Our soil test report or soil test kit, powered by soilkit.com, provides a warning to the end user saying, hey, here are the results of your soil test, but know that there is a potential fertilizer restrictive ordinance in your area. And so it links directly to that. The powered by soilkit.com, the data that is coming off of this platform is going to provide useful data sets to allow us to further refine our fertilizer recommendations. What we desire, instead of 3 regions in Florida, we really want to get it down even to the zip code level. And let me show you just briefly how some of this information is being used. So 2 maps of Florida. And so this is at the county level. And so the one on the left is showing our phosphorus in Florida. And the map on the right shows our soil pHs here in Florida. And again, this is at the county level. As more data comes in, we'll even be able to refine this down really even to the zip code, even to the subdivision level as well. Now, know that the data that's coming off of this is anonymized. And so nobody has access to this information, especially the confidential business information. Those of us at the University of Florida, we never see any of that. I just see the numbers from the soil test report. But what we see here is across the state of Florida, there's a lot of variation, even in our phosphorus levels, even at the county level. And then we have tremendous variation in soil pH, as evidenced by the very first question that Wendy asked you, what are the soil pHs of your landscapes across Florida? And so this information is going to be very, very helpful for us to be able to further refine our recommendations. Now, very quickly, when we look at nutrient recommendation guidelines, again, I said kind of the old model was low, medium, high, very high, but we lack calibrated responses for that. And so we're starting to switch some things up, at least in the turf world, to where we talk about sufficient, not sufficient, right? And so again, so we look at these recommendation guidelines. Of course, nitrogen is going to be based on the species that you're growing. Is it zoysia grass? Is it Bermuda grass? Is it Bahia grass? From the turf standpoint. Then when we look at phosphorus, about a year ago, I was able to get our recommendations changed. And now it's just a number. It's not this low, medium, high, very high thing. It's just if you are below 20 parts per million, Malic 3, then you probably could add some phosphorus and you likely will get a response. If you're above 20 parts per million, Malic 3, don't add any phosphorus. And so it's just now these thresholds. If you're below the threshold, you likely will see a response if you apply a nutrient. If you're above a threshold, there's no need to apply a nutrient because chances are you're not going to see a response. When we talk about potassium, basically we apply when a soil test is less than 40. Now we know, again, because of our tremendous rainfall that we can get in Florida, a lot of our soils are going to test low in potassium. And then we have a few other numbers as well. Our IFAS, these new soil test kits are available through the UF IFAS Extension bookstore. They're available there. We are on Amazon.com now. And then all 67 of our county extension offices have these soil tests available at the county extension office for pickup. These soil test kits are essentially pay on use. And so as you purchase the kit, it becomes activated and then off it goes. Last two slides, and then we'll kick over and show you the screen, in the portal. We have seen some folks that are kind of trying to capitalize on this, and they're illegally using our logos to promote some different soil test kits. This one here in particular, this is not the University of Florida soil test kit that is there. And so I'm going to stop sharing my screen. And then I'm going to pull up the website because I want to show very quickly what the online portal piece looks like. And so this is Soil Kit 365. Basically, you would log into this. My screen's going to look a little bit different because this is what I do. We'll scroll down here and we'll find a report. So here is one. And so this is a Bahia grass site. This is actually a pasture grass. And so one of the questions, yes, we have all the lawn grasses in the new soil test. You can do garden soils, you can do citrus trees, you can do really about anything. But what you don't want to do is test potting soil. Or if you have raised beds that you have amended with potting soil or compost, chances are you're going to get some erroneous values coming back from these. But so here, UF IFAS extension, you see the results. This sample was sent off on July 23rd. Click over here. Here we see the soil analysis. And so you can convert from pounds per thousand, pounds per acre, or parts per million. So depending on how you want to see the data, most of the time in the landscape, we talk about pounds per thousand. And so here, we'll come down here. Here's where you're going to see the soil sample results. Boron, calcium, copper, iron, potassium, on and on. And then you see the numeric values for these various elements. And then each of these have a little bit of information here. It tells you what these elements are used for in the plant. Let me go back up here. If you're kind of geeking out and you want to see parts per million, you just toggle back to that parts per million, come back down here, and now we see part per million values as opposed to pounds per thousand. So all that math has been done for you. You will also see recommendations that are being made. Let me kick back up here to pounds per thousand. You'll see recommendations. So this is a Bahia grass. Basically, we're going to recommend a pound per year on Bahia grass. Our phosphorus is a little bit low, and so it's going to recommend a pound per thousand. Now the law kicks in and says, I can only apply a half a pound at a time. Over a year, it's going to recommend 2 pounds of potassium as well. Now, there are also product recommendations that come through the soilkit.com portal. UF IFAS is not making those fertilizer recommendations, particular product recommendations. The soilkit.com is doing that. Now, I've worked very closely with them to make sure that we're not recommending products that would go against what the science is suggesting. And so, for example, you will never, if the phosphorus is coming in above that 20 part per million Mehlich 3, you will never see a phosphorus recommendation coming down from this. Notice up here in this big yellow banner here, warning, fertilizer restrictions such as blackout dates vary depending on your location. And you literally can click this Florida fertilizer ordinance, and it says, in my case, because I'm in Santa Rosa County where this sample was taken, it'll say no fertilizer ordinance reported at this time. If you are in Pinellas County, it will pop up and it'll give a warning saying, hey, there is concern right here. And so I think I've talked enough, Wendy. Let's field a few questions. And
Okay. Thank you. That was really good. You covered a lot there. And all right, I'm going to try to there's a question about foliar feeding better than considering that the soil is such a determining factor.
So the answer to that is depends. We know, for example, with our micronutrients, when we think about iron and manganese in particular, we know that it's within, and we've published these papers, within about an hour of applying iron and manganese to Florida soils, no matter where you are in Florida, those elements are oxidized within about an hour. And so you will not get root uptake of iron and manganese at all. I mean, very, very low. And so in that case, foliar makes a lot of sense. It makes the best sense, to put those elements out through the foliage.
Maybe related, but probably not. When you were talking about the gaseous loss and a little bit about the atmospheric deposition, could you break that down? What is meant by gaseous loss? How much gaseous loss is there? And then if you could address a little bit about the atmospheric deposition again.
Sure. So atmospheric deposition, as it rains, there are particular elements, that are in that. Now, it's not like it was 30 years ago. A lot of industrial smog and different things have been cleaned up. And so we don't have, especially sulfur and some of those things. And so we don't see those things. So just as the rain falls, it's picking up these atmospheric borne elements, and then they land on the ground. A colleague, Mary Lusk, researcher at our facility in Baum, is doing some really cool work, just looking at dust and pollen and stuff that sticks to plant the canopy, the trees. And as the rain comes down, it washes all that down to the ground, and it delivers a lot of nutrients. Now, gaseous losses, so nitrogen is constantly in a state of flux. It's moving around, and you do see some ammonia losses. You see some nitrogen gas losses. So, the air we breathe is what, if you're a scuba diver, I think you probably better know this number. The air we breathe is what, like 72% nitrogen. And so it's just a constant flux. And so nitrogen that is in the soil can outgas, and it's very, very low, extremely low. And in fact, work that's been done in turf is it's incredibly low. And probably not a major source of loss. We do see some denitrification. So like in wet soils, that nitrogen can change as well. But again, very, very, very low levels.
Great, good explanation. If anyone wants to just dive into the nitrogen cycle sometime and become an expert at that, I would encourage you to do it.
There's an EDIS, let me interject. There is an EDIS publication on that, extension publication on the dynamics of nitrogen. There's several, actually.
It's pretty fascinating, isn't it?
Yep.
I think so. Okay, this is my favorite question. I don't play favorites, Bryan, but this is my favorite of today. My impression is that the service providers caring for lawns and landscapes in the community pay no attention to soil testing, applying uniform treatment from property to property, using theories that are almost guesses when results are unsatisfactory. For licensing purposes, is there any state expectation of these providers that they test and use scientific information to treat? This is why we love master gardeners, right?
That's a really good question. Yes, 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 and yes, I think is the answers. If I had it my way, our lawn care applicators would move away from a one size fits all. Um, I mean, how is that any different than if we all went to the same doctor and the same doctor told every one of us to do things exactly the same, right? Um, it wouldn't work. But why do we think that it will work in the landscape? And so, um, unfortunately, a lot of the larger lawn care companies are much more cookie cutter approach, and so that creates a challenge. I think where the beauty, of a soil test report like this, really it's soil test, it's tissue test, and it's water test. I mean, there's a lot of variables. When you go in and troubleshooting, the problem can be a real challenge. And so soil tests provide a foundation as to what's happening out there. A lot of times that will check a bunch of the boxes. But then sometimes the problems are more complex. What are the biotic and abiotic stresses that are being imposed on that particular site? What are the conditions? And so to the question, to the regulatory side, yes, I mean, commercial applicators must be trained, they must be licensed, right? And to get a fertilizer applicator's license, you have to be trained in the green industry best management practices, right? And so, and there's a lot of continuing ed kind of requirements of that, but there's a huge turnover in the market. There's not a ton of enforcement that is out there, and so it's really kind of a mess. But I am supportive of obviously a lot of education. I think it's important that we use evidence, and so part of that evidence is these soil tests. To troubleshoot these problems and move way past that cookie cutter approach. So,
right, that's a great analogy about the physician. So there's a few questions regarding this. The old soil test is still ESTL is still happening. The extension testing lab is still there. But so the question is, should we encourage the old test, the new test, purchasing from Amazon, going through us? What should that recommendation be when we're at the plant clinic or at the farmer's market or at the exhibit, passing out the information?
So the soil test results, whether it goes to soilkit.com or the Extension Soil Testing Lab, they're both using Malic 3 soil test extractant. Right? So the results are going to come back very similar. There is a cost factor. Now, the soilkit.com is around $30, right? And so the test, if you send a test to Extension Soil Testing Lab, it's $10. And you're going to get a basic test, but you've also got to pay to ship the soil to the lab. And then if you want organic matter, it's another $10. So you got $10 for the test, $10 for organic matter, $10 on average to ship it. So you're at $30. This is $30. And it includes, when you open it up, it includes a prepaid mailer. So your shipping is paid for. So you literally, everything that you need is in this little kit. I mean, you pull it out, you've got the little soil test bag. This is the prepaid mailer that's there. Put the soil in this bag, stick this bag in this bag, stick it in your mailbox. Off it goes. Last Friday, I submitted 6 samples. I got the results Wednesday, all electronic.
Okay. Over the weekend.
Over the weekend. And so they went in the mail Friday. They hit the lab on Monday. I got an email Monday morning saying your samples have been received. And then yesterday, literally, here come all my results. I'm doing organic matter. Again, when we develop this, I want organic matter because I know that as landscapes age and you have an increase in organic matter, they need less fertilizer. That's just a fact because that process is going on. And so we're using that data, that organic matter data in particular, to help us improve our recommendations. And so same test, what am I going to recommend? I mean, do you want a report that's fairly easy to interpret and understand? The soilkit.com is so much easier. And you're getting really the same. it just really kind of comes down to preference.
Okay.
Amazon, it looks, I just glanced this morning, Amazon is about $1 or more a kit. Um, IFAS bookstore is about $1 less than Amazon. Um, if you go into a county extension office anywhere in the state of Florida, they should have these. You can pick one up for free. I mean, you walk out with it and then you register it. One of the things I did not mention, when you register the kit, it pops up and there's an app. And so you maybe don't know how many square feet is your lawn. There, when you pull this up on the smartphone device, iPad, iPhone, you literally can put pins around your yard and then it will tell you what your area is. And then when those recommendations are generated, it will tell you, you have 4,000 square foot of lawn. You need 28 pounds of this product. It is that specific.
And so it's of this product. So they're suggesting if you're using a 15015, this is how many pounds per 1,000 square feet you would need, which is the big difference between the soils lab, because that's the math I did as an extension agent to give that to them. And that meant that we needed to have another conversation or they had to come back to the office. So that level, I think also the dashboard of what it looks like is much more compatible with how people are consuming their information these days, okay,
Let's see. A
so
question that popped in about, is this soil kit is a nationally available kit?
mm-hmm.
Um, so so soilkit.com has a white label. I mean, you could go down to Lowe's right now and probably see a white label with green lettering. It's not the UF kit. Now, any soil kit, whether it says UF or otherwise on it, sold in the state of Florida is going to have Florida recommendations on it. That is something we were insistent upon, but they started earlier than before our partnership. The kit that says Florida on it, you can buy it nationally. You can use it in Iowa if you wanted to, but it is going to come back with Florida Malic 3 recommendations.
Perfect.
There is an Auburn kit, so if you're an Auburn diehard, you can get you an Auburn kit. Um, um, our Site One landscape supply stores in Florida, many of them are Ewing landscape supply stores. Our kit is now in those stores as well. But so yes, you can buy the kit from a white label nationally and use it anywhere. So
Okay. So from extension agent Teresa Bedurick down in Pinellas County, now that the USDA hardiness zones have shifted, are we making shiftings for our north central and south based on those that zone shift? And I need, this is a big discussion we have to have, I think, organization wide as far as our recommendations go. So what is your
fabulous
thoughts on
question.
that?
Fabulous question. And yes, Dr. AJ Lindsay, my counterpart in Gainesville, and I are working through that. The hardiness zone maps is really interesting because hardiness zone maps are based off of cold weather, right? And so it's first freeze, last freeze dates. Um, and so yes, we're looking at that. Um, our biggest changes will be the North Florida line because if you look at North Florida, where the hardiness zone maps goes up and it really kind of trends up around the St. Johns River.
Kind of Highway 40, we used to say, but now it's going to be much more north than that.
And so, and it literally is the river. I mean, and they talk about the river effect. And so, but yeah, those are shifting. And so that's again kind of where some of this AI and this data scientist, somebody that I get more than about 8 columns on a spreadsheet and I start melting down personally. But these folks that are used to huge data sets, yeah, most definitely that is the direction we're moving, and that's where site specific recommendations come down. So with the soil kit, we can overlay those maps, and so that if you were in Palatka, um, then that recommendation could be very specific for Palatka. If you were, you know, Lake City, or up in there. I mean, you literally could see these things changing. Um,
Definitely.
it's going to take a little more
Definitely.
research, but it's good stuff. That's a great
All
question.
right, I'm going to ask you maybe two more questions. So, a lot of master gardeners are very serious about their mulching and their soil amending and their, soil building, because we do focus on that quite a bit. And so they haven't actually done a soil test because they know they're improving and their soil continues to improve. So, do you think it's still appropriate or good use of money to go ahead and test that soil?
Yes, I think it kind of comes down to, what is that relative percentage? I mean, if you look at, the soil and, like a raised bed, for example, and you can see all that perlite in there and you can see all those, pine bark and different stuff, probably not. But where we're amending soils, I think it's of great value. We've got a huge push to, composting our landscapes pre-establishment. On top of the world communities, where some of this work's been done with these composting and amending the soils pre-plant for water holding capacity. I think that's critically important information to know because when we add the compost, we're adding nutrients, right? I mean, in some cases, a lot of nutrient. Now, it's not
Mm-hmm.
all plant available right now. We're actually doing the research on that right now to try to understand that better. But um, the flip side of that is if you're composting, then you probably ought to back off that fertilizer. And it's no different than if you're spraying reclaimed water in your landscape, we probably ought to back off that fertilizer. You know,
Right.
what level of
Absolutely.
backing off, we're still wrestling through that.
Well, and I think you're looking for nutrient deficiencies, and what did you call it? Winning that beauty contest,
Yeah.
making sure that things are being productive. So, all right, I think we're gonna go ahead and wrap it up. The soil.com is slightly more expensive, but the way that Dr. Unruh explained it, if you're going for a full test at the lab, it's almost equal with the mailing, and then the ease of understanding. You want to make a little bit more comment on that?
Yeah, it's the other thing with the portal, and they're adding additional, components and pieces and parts, and I'm working with them on that. But um, the fact that you can go in and see trends over time as well, you're not getting this piece of paper back. Um, there's also a button on there down at the bottom. I didn't show it, but you can share your results. And so maybe you have a landscape contractor, and you've done this on your own. You literally can push that button and share those results with your landscaper. You can email your results to the county extension agent. The other side is the way we have this set up. We have offered all of our county agents in the state of Florida that are using this, we give them access to the portal. And so they actually can go in and see kind of what's happening within their county, um, as well. So it's
All right, just one more time. This is our last question about the sampling and how many core samples to kind of take from that 2,000 or 3,000 square foot yard. And the person, Mark, is talking about that example that you used of the front yard versus the backyard with the bulkhead. And if you could just mention that one more time so people can have a real good understanding of that.
so I think, on a traditional size front yard, traditional size backyard, maybe 10 samples, from around the landscape, 4 inches depth. Peel that organic matter off. You don't want to include the organic matter, the thatch, the grass blades. Leave that out. Put it in a bucket, stir it up, pull that sample off. If the front yard and the backyard are very similar, you could do one test for the whole landscape. If there's some dissimilar, or if they're larger landscapes, we typically say one soil test per 10,000 square feet. Um, you'll also see, and there's a little bit of price savings, but you can buy them in a twin pack. And that was set up that way so that you can do a front yard and a backyard, or, this year, next year, as well.
Good, good. All right, Bryan. Thank you, Dr. Unruh. This was fantastic.
Yeah.
And I think we got a lot of knowledge and people know where to find you. Of course, the recording will be posted. And would you be okay sending us a PDF of your slides and we can post that alongside of the recording? Okay, that would be wonderful. Everyone take the survey because we want to get some good results back. And we will see you next month at the webinar. Thanks, everybody. Thank you, Dr. Bryan.